Okay, right. So 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 last time, so just recall what we have seen last time. So let me recall little bit. So we have an idea of vector, right? So the vector mean we understood we have a directed line segment that has a initial point say A and it has a terminal point say B, right? So the vector mean it start from the point A and it will end up at the point B. So this kind of directed line segment we called vector. Now once we consider a coordinate, the where the vector appear, x axis, y axis and g axis, if the vector in the three dimension, so this point is A. So if we consider x axis, y axis and g axis, you know then the vector, say this vector we called A vector. Okay, man, AB vector. So if we write the array like this, say A vector is AB vector, so it start from A and end up at the point B. Hmm. So if the point B has coordinate A comma B comma C, right? So let's say the coordinate of B point is this, then A vector you can write. So A vector equal to nothing but A, B, C. These are the component, right? So this is called the component form. So any point, in space, we can think it is a vector that start from the origin. Say, okay, now let's say this I said called it is O. Start from the origin, it is O, and end up at the point B. If the B has coordinate A, B, C, then A vector we can write in the component form. The three components will be A, B, C. And the linear form, if we consider the unit vector, along this I cap and this along unit vector, let's say j cap, and along this k cap, then A vector we can write as A I cap plus B j cap plus C k cap. We'll write like this. This is called the linear form. Okay, so this we did. So anyway, that now, so any vector is a directed line segment, and any vector has three component always. Okay, if you are considering the vector in a plane, then the last component will not appear, the C component, last part, the K, you can see the coefficient of K will not appear. Now we know that we can add two vector, right? We have to, so far we know that if we have two vector, if A vectors and A and B are given vectors, right? So this means they are two directed line segments started from origin, you can think. So then, what we can find out? We can find out A vector plus B vector, right? We can add them, right? Okay. So this is addition we did last time, right? And we can take the scalar multiplication, right? So that means if you take a scalar lambda, then you can multiple the vector A by that scalar. Okay. So basically how the addition defined. So if you take A vector here, let's say this is A vector, and let's say this is your B vector, right? And then the somehow defined, so you complete the parallelogram, then this line segment, this corner will give you the sum, right? A vector plus B vector. Okay, Mayan, it's clear. So we did it, right? This the addition of two vector we did, right? And we also defined the magnitude, right, of a vector. You know how it is defined? Magni. So Magnitude how defined? So it is nothing but length of the vector. So if your vector is, let's say, a b c component, if you have, then the magnitude of the vector, we write like this, is defined by basically square root of a square plus b square plus c square. This is nothing but length of the vector, right? Length of a vector. Last time we did this kind of thing, right? Okay, Mayan, is clear? Hello.
Yeah.
Okay. Now today we see new concept that called the dot product. So today the goal is basically how to find angle between two vector. Okay. How to find angle between two vectors. We see that here. So if we have two vectors, mean directed line segment, then how we find the angle between those two directed line segments? So let me draw here two vectors. For example, let's say we have a vector here, something like this. Let's say this is a vector, and one more vector, let's say here we have b vector. Okay. So now we are interested to calculate this small angle theta. Okay, fine. A small angle, that is the very much
Fine.
small. Yes. So let a and b are two vector. Let, yes, a vectors and b vectors are two given vector. We want to find, so if you have two vectors, so then you know the components of AB. So both vector AB components are known to us. Now using those components, we want to calculate the angle between those two vectors. So let's say AB two vector. We want to find the angle theta. Definitely theta will be between, 0 to pi, because we are interested to the small angle. Because someone, some person can think that, okay, let's take this angle, but we cannot take this angle. Okay, we will focus on the small angle. Okay, right. We want to find the angle theta between a and b. So now the question, how to find the angle between these two vector a b. Let's say the angle theta. So to find out the angle between two vector, we define the dot product. Okay, man. We will,
Yeah.
yes, okay, we will define, yes, dot product. This is very much important here. So the dot product between AB. Yeah, between A vectors and B vector. Okay. So let A vector. So let A vector equals to, it has the component. Let me write it here in the for A. The components are A1, comma A2, comma A3. So and B has the component B1, comma B2, comma B3. So let's say we have two vectors, A vectors and B vector. A vector has component A1, A2, A3. B vector has component B1, B2, B3. Okay, right? So now the dot product A dot B is defined by, let me write it here, the definition. A dot B is nothing but A1 B1 plus A2 B2 plus A3 B3. Okay, Mayan is clear. This is the definition for the dot product. I'll tell you how this dot product help us to calculate the angle between two vectors. Is the definition clear, Mayan? Dot product. If you have two vector A and B, say A has component A1, A2, A3, B has component B1, B2, B3, the dot product is given by this way. Okay. So let's say example. A vector, let's say given by the component are, let's say 1, 2 and minus 1. And let's say B vector has component 3, 2, 5. Okay. Now A dot B, if we calculate, can you tell me what will be the A dot B? Hello? Can you tell me, Maya, what will be the dot product of these two vectors?
3 plus 4
3
minus
plus 4 minus 5. Yes.
5,
So
yeah.
we're getting 2. So the dot
2.
product, yes. The dot product of this vector is 2. Yes. Fine. Right. Okay. So now we can, if we have two vector and we know the components of those two vector, then we can easily calculate the dot product. Now we see using dot product how we can find out the angle between two vectors. Okay. The next concept is this. So let we have two vectors. Let A vectors has component A1, A2, A3, and B vector has component, let's say B1, B2, B3, and say and suppose theta is the angle. Of course, theta is in between 0 to pi. Pi mean 180 degree. Suppose theta is the angle between A vectors and B vectors. So is this clear, man? We want to find theta. We will write. So the target is here. So we will write. We will find a formula for theta by using, the dot product. Okay. This is our target. Clear, man?
Yeah, fine.
Okay. Okay. Now see how we do this. So see what we have given. So we have given a vector here. So a vector may be this place, and let's say the b vector is here, this place. Okay. Okay. So let's say this is the terminal points of a vector. This is the terminal points of b vector, and both start from, let's say, origin O. Let's say this is called A. This is called B. So OA vector, let's say A vector, and OB vector, let's say B vector. Now just we use here the basic geometry. So let complete say triangle here. So if you complete a triangle, so what you get? So you have to join A and B. Let's say join AB. Now put a array. So you can put from A to B or B to A. So tell me which direction I take here. A to B or B to A. Any way you can take. So tell me which one you want. A to B or B to A.
A to B.
A to B. Okay, so this direction you took. Okay, very good. So now we know this angle is theta, right? Okay.
Yeah, sure.
Okay, very good. Now see, just recall, actually, Mayan, that if you take a triangle, man, so let's say you have a triangle like this, and this is called the triangle formula. This is A, B, let's say this is C, and this is small a, this is small b, and small c. And if you know, so now, can you remember, man, that we did this formula in trigonometry? A square equal to b square plus c square minus 2bc into cosine of theta. Can you remember, man, this formula in trigonometry we did, right?
Yeah, correct.
Yes. So let's apply here that formula. So this mean AB, the vector AB, that length, the length, AB length square is nothing but OA length whole square, right? Minus plus OB length whole square, right? Minus 2 into OA length, OB length of cosine of theta, right? Fine, is clear. Okay. Okay. Fine, man. It's clear.
Yeah, it's fine.
Right. Now see AB. What you can say AB? See, OA vector plus AB vector is nothing but OB vector, right? So clearly, just I'm trying to reduce. I'm trying to, the I'm trying to prove the formula for theta using dot product. So that's why I'm doing this. Okay. So now what you can say here, AB vector equal to what? AB vector equal to, if you know only the formula, that is enough for doing exercise, but I'm trying to tell you here. So AB vector equal to nothing but, OB mean what? OB mean B vectors minus A vectors. Okay, man, is clear? Okay.
Yeah, fine.
Okay. Now let me go little bit the previous page where dot product I defined it. So this page. Okay. Look at this. If I put here A dot A, then what happened, Mayan? A dot A, if you calculate, see in the definition you get A1 into A1 plus A2 into A2 plus A3 into A3. So this is nothing but A1 square plus A2 square plus A3 square, right? So this is nothing but the magnitude of A vector square, right? So what we are getting, that A vector magnitude square is nothing but A vector dot A vector, right? Right, man?
Yeah.
So the A vector, yes, magnitude square. So okay, one thing I forget to tell you about dot product, that I think I need to tell you here. So some property. So let me list here. Property of dot product. Property of dot product. So sorry, I forget to tell you. So let me list it here. So the first property that I just prove here, that if you take any vector, then if you take the norm or absolute value of that vector, that is nothing but A vector dot A vector. And then second, if you take A vector dot B plus C, you get from the definition, this is nothing but A dot B plus A dot C. Okay, man? And similarly, the third property, that it is also from the right side you can distribute. The dot product can be distributed from the right side. So B dot A plus C dot A. Now dot product is commutative. A dot B is the same as B dot A. Okay, right? And fifth, if you take A dot lambda of B vector will be the same as lambda of A vector dot B, you can bring lambda outside, then A dot B. Okay, mine is clear. This property, 5 property, you can prove using the definition of dot product. See, we have definition of dot product here, right? A dot B equal to what? A1 B1, A2 B2 plus A3 B3. Now these all 5 property you can prove using this definition. Okay, Mayan? Okay. Hello.
Yeah.
Okay. Just you believe this, you can prove this property, or should I go through this proof?
Yeah, can you go through those two?
This one, all these 5.
Yeah.
So just can you believe me for 5 minutes? If you believe these five, you know, these 5 properties of dot product, then I can prove the angle. So after proving angle, I come back to here. Can I do that?
Sure.
Okay, just believe these 5 property are true for dot product. Then let me prove the angle. Then I come back to the proof of this property. Okay, Maya. Right. Right. Okay. So let me go to that proof now. So just knowing that. Okay. So we have this. Now what we do, let me go to the next page. So this is nothing but AB vector we know now B minus A. So we have now B vector. So B vectors minus A vector. So AB vector. So that square, modulus square. Now what we have here? Now this is nothing but, if you look at this, then this is nothing but now OA vector, that is A vector. So OA vector is, this is A vector. So A vector absolute value square plus B vector absolute value square minus 2 into A vector absolute value, B vector absolute value, and then cosine of theta. Just I put, since AB vector equal to B vector minus A vector, and OA vector is nothing but A vector, and OB vector is nothing but B vector. I just put in this expression, everything. So here, this I put B minus A, this I put replace by A, this I replace by B, this similarly. Okay, Mayan? Now just,
Okay.
yes. Now just replace this by dot product. As we know, any vector if you take, then dot product you can replace by, the magnitude. You can replace by. So x vector magnitude is what? This is nothing but, square is nothing but x vector dot x vector. So we replace this by, so b vector minus a vector, this dot b vector minus a vector. So this is nothing but a vector dot a vector. This is nothing but b vector dot. If you want, you can replace. Otherwise, you can write like this. So instead of, just you replace the right hand, the left hand side by dot product. This side you not need to change. Leave as it is. Okay. Cosine of theta. So this is this side. So now if you apply the distributive, what happened? Then this will be b vector dot b minus a, right? Minus a vector dot b minus a, and this side will be the same as it is. So this square plus b vector mod square and 2 into So this will be basically 2 into A magnitude, B magnitude, and cosine of theta. So now this is, did you understand, Mayan? This from here to here by distributive, right? So let
Yeah,
me tell
correct.
you, yeah. So let me tell you by distributive, this property, distributive. Yes, I'll prove that. You then believe totally. Yes. So now again distributive. So B dot B minus B dot A. I distributive B over this. Now again I distributive A over this. So this is minus A dot B minus minus plus A dot A, right? So this will be what? Then A absolute magnitude square plus B vector magnitude square minus 2 of A vector B vector of cosine of theta. So now this is what? This is nothing but, B dot B mean B absolute value square, and then we know B dot A mean you can replace by A dot B, and you leave it is A dot B. So this is nothing but A absolute value that square. So this side will be A absolute value square plus B absolute value square minus 2 of A absolute value B absolute value cosine of theta, right? So now see, Mayan, B absolute value appear both side we can cancel out. A absolute value, A absolute value we can cancel out, right? Mayan, is clear? So now what we are getting? We are getting minus 2 into A dot B, right? This equals to minus 2 into A absolute value B absolute value cosine of theta. Is it okay, Mayan, so far?
Yeah, it's fine.
Very good. Now, if you interchange both sides, cosine theta this side, the cosine theta will be what? Cosine theta will be A dot B divided by absolute value of A and absolute value of E. Right? Mine is clear? Yes. So what we are getting? We are getting cosine of the angle is nothing but we calculate A dot B and divided by norm of absolute value magnitude of A divided by magnitude of B. From this, we can calculate the angle between two vectors. See, the left hand side, contain the angles, and the right hand side contain the dot product. So we have written the angle using the dot product. Okay, Mayan, that was our target, right? We wanted this, right? That angle we will write using dot product, right, Mayan?
Yeah,
Yes.
fine.
Yes. So let me tell you how we start. So basically, we took two vector AB and we want to calculate the angle between those two vectors. First, we define dot product. If you know the component of A vector A1, A2, A3, B vector B1, B2, B3, dot product is defined this way. A dot B equal to A1, B1 plus A2, B2 plus A3, B3. Now, some property dot product will satisfy this property. We will prove in the next lecture that this dot product having this 5 property will prove this. Okay, Mayan? But we believe this 5 property and we want to write down the angle using dot product. So that we did here. So first we make a triangle AOB, then use the triangle law that this AB length square equal to OA length square, OB length square minus 2 into this and cosine theta. AB vector we replace, OA vector replace, OB vector replace in the next page, right? Here we replace by this, and this we replace by dot product, apply distributive property, simplify little bit, getting cosine theta equal to this. Okay, Mayan?
Yeah, fine.
Okay, let me send you the new link. Then we saw the property of the dot product, that 5 property I have written here. Those we believe and prove the angle. Okay. And then I talk
Okay,
you, yes, I talk to you little bit on the dot product, angle, then solve the exercise. We'll solve exercise. Okay, man.
sure.
Okay. Let me send you the new link. Then we see the this 5 property. Okay, sending. I stop here the call. Okay.